set let u equal 1 minus x squared? Or would it be let u equal, is that arcsine x?
Yes. Yes, I completely agree. I don't like this notation because it could be confusing. I do like this. It's easier for me to type because I don't have to put a power. So for lazy people, this is easier. But it's also, sometimes this is confusing and sometimes students say that it's 1 over sine and not think that it's the inverse function. Yes, it is arcsine.
Let u be arcsine?
Yes, I will definitely denote let u be arcsine. Only if du is in the problem. So when we differentiate arcsine, anyone remembers what we get? This is not a good color.
1 over square root of 1 minus x squared.
Thank you very much. Of course, dx. So this is our du, and u is in the denominator. du over u. So dx over this. Always remember, this is the same with dx over this, because it's dx over 1. Okay? So then I have du, and u in the denominator, so I know what is the antiderivative of 1 over u.
Would it be natural log?
Do not forget, I didn't say that you did. I'm just anticipating, so please. Plus a constant c, and of course I have to replace it. How do we feel about this one?
Okay, so we don't do anything with du. Like after replacing the 1 over square root of 1
There
minus
is
x
no
squared.
integral without dx, and there is no integral without du. So when the integral disappears, du disappears. So when I calculate this, I get this. So when I find the antiderivative of 1 over u, the integral goes away together with du. Is that okay?
Oh, yes.
Do we need other indefinite with substitution? Did you find anything in WebAssign that you want to work on? Anything? Any questions? Are we okay with this, or yes?
I'm okay with that. I just remembered something. Could we, I know there's a problem on the homework about absolute values. Could we do a problem like it?
Yes. One of your colleagues asked the same thing in the study group. And this is all going back to the 2 options. That's all you need to do. So the absolute value gets replaced by these 2, and then you have to split the integral into 2 parts.
Okay, that's what I did. I just want to double check.
Yep, that's all there is. So this is going back to chapter 2, when we graph these functions, the piecewise defined functions. So the absolute value of x minus 4, it's either this or this, of course, greater than or equal to 4 or less than 4. And then I split the integral at 4. So it was from -1 to 6. I'm going to post this, of course, after class. They're all in the study group notes. From -1 to 4, from the appropriate one, -1 to 4, from the appropriate one here. And from 4 to 6, 4 to 6 from the appropriate one. And then the rest is just calculating the integrals. Is this good enough, or we want to make one up?
For me, that was good because I just wanted to check that like my splitting up was correct, but I obviously can't speak for everyone.
Sure. Do we need more indefinite, or can we look at examples with definite? Anyone? So can we move on now to definite then?
Oh, yes.
Okay, so yes, go ahead. Dylan, go ahead.
It's Colby who's speaking.
I'm sorry, Colby.
After we're done with that definite integral thing, will we be going back for more chapter 5 review?
Of course.
Okay.
Anything you want. So let's take a look at 71. The integral from 0 to a from x the square root. So are you feeling a little bit better about this now? Any progress, you think? Anyone?
I think so, but I do have a question.
Yes.
How will we know when it's necessary to substitute? Will it say specifically to do that?
Well, it's a very good question. For example, very good question. So for example, if I have something like this, I'm going to make it from 2. In this particular case, I have one term in the denominator. I will expand the numerator. Of course, it's a definite integral. It's continuous on the interval 2 to 4. It's always positive on 2 to 4, so the answer has to be positive as well. Okay, so I expand, and I have x, I'm sorry, I meant to write squared. So x squared plus, I'm not going to take to the 4th power, plus 1. But if it's the 4th power, that's more difficult. So over x squared dx, but just because this is one term, so I will simplify it like this. X squared over x squared is 1, 2x over x is 2 over x, and 1 over x squared dx. So then I know this is x, this is plus 2 natural log of x, and then minus 1 over x from 2 to 4. On such an integral, I will not think of a substitution, and the substitution will not, cannot even be found. But when I look at this problem, I'll say, what do I do with this? This is a function inside another function. That is hard to work with. I don't know what to do with it. Also, the square root is in the numerator. It's not in the denominator. I will not think of taking or using the square root. Sometimes it may even work in certain situations. Who knows, depending on the problem. But no, I would not look at or think of using u as the square root for this. So how do I continue? What do you think? Any tips, any suggestions? Anyone?
Would it be u equals x squared plus a squared?
Of course, because du equals 2x dx. I have the x and I have the x. That's all I need. A little number as a factor, only a factor, very easy. 2x dx, 1/2 in front. Do not copy the limits of integration, please. Okay, I should have said. So between 0 and a, this is positive, this is positive. The answer has to be positive. This is continuous on 0 to a, so then I can proceed. Okay, so
also a obviously is a constant. That's why we didn't.
Right.
We didn't.
And I think yes, I'm sorry I didn't copy it. That's why also a is positive. Yes, we cannot have two variables in an integral, in a single integral. Once you get to Calc 3, you will see there are double integrals or even triple integrals dx, dy, dz. But that's Calc 3. In Calc 1, we can only have one variable. And the variable is x because I only have dx. And also 0 to a is a constant. Yeah, perfect. So then I know what this is because this piece is u. So this is the square root of u, or u to 1/2. And these three are du. So this is 1/2, u to 1/2 plus 1, which is 3/2, over 3/2. And sorry, so when x is 0, u is a squared. When x is a squared plus a squared is 2a squared. The lower limit of this integral is a squared. The upper limit of the same integral is 2a squared. So 1/2 u to 3/2 over 3/2 from a squared to 2a squared. And now we continue.
How did you get that new integral again?
What do you mean by the new integral?
Not integral, interval. Sorry.
Oh, yeah. So when x, so the lower limit will give us the lower limit for u. The upper limit will give us the upper limit for u. The lower limit, 0 plus a squared, is a squared. The upper limit, a squared plus a squared, is 2a squared.
Okay, I see.
Better? Okay, so then...
And we always do that for substitution. But, like, there's, yeah, we always
for
do
definite
for
integrals. For definite integrals.
Okay.
You cannot copy the interval for x as an interval for u, because x and u are not the same. U is x squared plus a squared. So if x if x is between 0 and a, u cannot be between 0 and a. That's not possible. So I cannot copy these limits here. If x goes from 0 to a, u will go from a squared to 2a squared. If I make the error of copying the same limits of integration, that would be completely wrong. Because u is a function of x. It's not x. If u is x, then yes, but u is not x. U is x squared plus a squared. So when x is 0, u is a squared. When x is a, u is 2a squared. Is that okay?
Thank you.
Better? So then we have, so 2 over 3, so this is 1/3. And we have u to 3/2 from a squared to 2a squared. Okay, 1/3 can wait patiently. I will plug in 2a squared everything to 3/2 minus a squared everything to 3/2. 1/3. So both factors have to be raised to 3/2. So this will be the square root of 8, or 2 the square root of 2, times the square root of a squared will be a to the 3rd, minus the square root of a squared is a to the 3rd. So therefore, I will factor out a cubed, so I get 2 the square root of 2 minus 1 over 3, a cubed. So the numerator is 2 the square root of x, the square root of 2 minus 1. The denominator is 3, and a cubed is outside. You can put parentheses if you want and put a cubed at the top. It doesn't matter. Same thing. Should we choose other definite integrals.
Where did the -1 come from?
I have two terms. When I pull out a cubed, I have to have two terms remaining at the top.
Oh, okay.
If I start with two terms, I have to have two terms. So that when I go back, a cubed times this is this, a cubed times -1 is this. Is that better?
Yes.
Perfect. Should we choose another? Yes or no?
Yeah.
I got my eye on two of them actually. Do you want to choose or do you trust me to choose? Okay, I got my eye on two of them here. One of them is 75. The integral from e to the fourth from dx over x, the square root of natural log x. What do you think about this? Any suggestions?